Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at this parcel which has arrived from Amazon. It's been sent by our friends at Kaiweets Tools. It's a digital multimeter for evaluation, so let's go and get unboxing. Okay, before we start to look at the meter itself, let's just take a quick look at the specifications. It's a true RMS meter, 6,000 counts, and it's got the usual selection of ranges you'd expect from this kind of meter. DC voltage ranges 600 to 1000 volts, 600 millivolts to 1000 volts. AC again 600 millivolts to 750 volts. DC current 600 microamps, which is useful for electronics, up to 10 amps. AC current again 600 microamps up to 10 amps, so again good for electronics. Resistance a 600 ohm range up to 60 mega ohm. Capacitance 10 nanofarads to 100 millifarads, so that's a good range. Frequency and duty cycle 10 Hz to 10 megahertz, and as you'll see it actually exceeds that. Right, let's actually have a look at the beastie in action. Okay, well, here's the parcel, come nicely packed as ever from Amazon. So we're just going to open it up and see what's what, and nicely protected inside there, as it says, digital multimeter. So let's have a look what's in the box. It's the HT118A. I'm just going to break that seal there, like so. And what we've got in the box, well, first of all we've got some instructions, got the meter itself, and we've got a box that contains the various accessories. So we'll just have a look what's in there. So we've got some batteries, two AA batteries, we've got a thermocouple, and we've got a set of probes. So all that's come nicely packed, survived the journey, no problem at all. So let's get them out of their plastic packets and see what it's capable of. Okay, so to fit the batteries, it's just a case of undoing that screw, this little stand and its back plate lift off, pop the two AA batteries in there, redo that screw up, and then she's good to go. Nice robust stand there, seems to sit quite nicely, and it's actually quite a smart looking meter. So switch on, and straight away lets you know it's switched on with a beep. Display looks very clear. We're on DC volts here. So when you do go to a range, it does flash around the connections that you actually need to use. Now, for most hobbyists and certainly for professionals, you're going to know which probes you need to plug in to which hole on the multimeter. But if you're new to this, or you're only going to use this occasionally, or electronics isn't the kind of thing you dabble with every day, I actually think that's quite a handy feature. It just makes it really clear, yeah, you need to use those, and most of the time it is those two. But then when we get onto the current ranges around here, of course, we need to use different ones. And if we go on to AC amps there, and then the largest current range, then it's those two. It's also got mains current live detector at the top here, and it's also got a backlight, which is quite nice. And I think if you continue to press that, or press and hold, yeah, you get a flashlight, which again sometimes seems like a gimmick, but there have been occasions where I've been doing something like this and the flashlight has actually come in quite handy. I've got a Weller soldering iron that has 3 LEDs on it, and when I got it I thought, yeah, I'm not going to do much with that, and I've discovered that actually it's quite good for lighting up circuit boards in sort of confined places, particularly in some of the old receivers that I dabble with. So not to be sniffed at, really. Right, let's get set up and do some testing of some of the ranges and see how she goes. Okay, so first of all I've got the unit set to DC volts, and I've got a My bench power supply just supplying a random voltage. My bench multimeter tells me that that's about 9.103 volts. So let's see what the Kaiweets makes of that. 9.11, yeah, so it's within 0.01 volts, which I think is pretty good. I'd expect meters of this type to be pretty accurate on voltage, resistance, etc. So we've not got too many concerns about that. So I've got some resistors here. Let's just randomly picked up some resistors out of my stock, and so I'm going to just pop the bench meter onto ohms. This should be, it's a 270k resistor. These are 5% tolerance, and that's saying bench meter is saying 2668, so 266.8k. So let's see what the Kaiweets makes of that. Go on to ohms. 267.4, yeah, so it's within 0.002 there, so that's absolutely fine, as you'd expect. What I do want to do is look at the frequency, and also this meter can measure duty cycle, so we'll have a look at that as well and see what results we get. Okay, so one of the things that this meter will measure is duty cycle. So I've currently got it hooked up to my signal generator, and I've got a frequency of 2.05 actually on the frequency counter, kilohertz, and I've currently got it set to 50. So it's a rectangular wave with a 50% duty cycle, and hopefully you can see the trace there on the oscilloscope showing that up. And if I now increase the duty cycle up to say 60%, as you can see, yeah, the meter's keeping up with that there, so still agreeing with the frequency and certainly agreeing from a duty cycle point of view. Let's go right up to about let's go to 80. Yeah, again still spot on with 80, and you can see on the scope that the slowly but surely the wave is closing up. I'm just going to change the time base a little bit there so you can just hopefully see a little bit more clearly what's going on. Yeah, slowly but surely the gap's closing up. So we'll go up to 90% duty cycle. There's 90%. Again, you can see almost closed up. Still tracking the frequency fine, still saying 90%. And we'll go right up to 99%. And you can see, yeah, just a tiny little gap there still on the scope. And at 100% duty cycle, it's still, yeah, that's exactly what I'd expect, because effectively now this is effectively DC, and sure enough the meter can no longer detect the frequency. So back to 99, and yes, she's picking up the frequency at 99% duty cycle and also correctly putting up the duty cycle. Let's now go right back. Let's go to about say 25% duty cycle. So yeah, that's 25%. Meter saying 26, pretty close. You can see it's beginning to open out, and we'll go back to 50. Now if you've got an oscilloscope, obviously the easiest thing to do here to look at duty cycle is to see it on the trace, but if you're into stepper motors or radio controlled cars or airplanes, radio controlled robots, actually being able to check the duty cycle of a pulse width modulating controlled motor is actually potentially quite handy without having to go to the expense of getting an oscilloscope. So I think that is a really nice feature, and it certainly is doing okay at that sort of frequency. Obviously it's going to be alright at a lower frequency as well, which is what you'd normally expect for motor control. So nice touch, well done Kaiweets, that's good. Okay, so I've still got the Kaiweets HT118A hooked up to my signal generator, function generator. I've now got it producing a sine wave at 1 Hertz. So what we're seeing there is frequency and duty cycle. It's not particularly applicable at the minute because this is a sine wave. But as you can see, it's actually managing to pick up the fact the frequency is 1 Hertz, which is ticking of a clock, so it's doing pretty good there. If I turn that down to 0 hertz, it does indeed pick that up. If we go back up to 1 hertz, just give it a moment or two. Is it gonna spot it? Yeah, there you go. Just took it a moment or two, 2 or 3 seconds. But to be fair, it has got to obviously take samples, and it's only getting a pulse every second anyway. So it's actually good at 1 hertz, which is absolutely excellent, really. As you'd imagine, it's perfectly good at 50 hertz. So I'm just going to go up to 100 hertz, and then we'll come off the hundreds. We'll go back to 0 for a moment, and now we'll go on to megahertz. So there we go, that's 1 megahertz, and the unit Kaiweets reckons it's 999.9. So let's go up to 5 megahertz. Yep, there you go, still pretty good. 10 megahertz. Yeah. Now the range, it has a 10 megahertz range, so above this point we're outside of its stated range, but let's just see what she's capable of. That's yeah, that's 15 megahertz, and it's doing okay. 16, yeah, 16 megahertz. 17, still doing okay. 18 megahertz, yeah, that's quite impressive. That's nearly double its maximum range. That's nice. 19 megahertz, yeah, let's try 20, pushing my luck now. Yeah, still managing 20 megahertz, very good. And we've started to lose it there as I go to 21. Yeah, that's no longer giving a correct result there. So let's go back to 19 megahertz and see if, yeah, there you go. She finds 19. It does manage 20 as well, but once you get above 20, starts to give an erroneous result. So back to 20, and yeah, it's picked up 20 on the way back down again. So considering we're not using screen leads to feed the instrument, I think it's doing rather well to pick up 20 megahertz there. So again, that's quite a nice touch. And if you're a hobbyist who needs a frequency counter for audio frequency and quite a way up the high frequency band too, then yes, this is capable of that. So good. Okay, so another range that's very useful to hobbyists in the electronics world is capacitance. Always good to check out what your capacitors are like. It has a 10 nanofarad range, so let's start there. This is a 10 nanofarad. Yeah, saying about 10.1, so it's okay at the small end. It has a claimed maximum capacitance measurement of 1 millifarad, but I think it'll probably do better than that. This is a 470 microfarad, and she's coming up with that at 511 microfarads. So yeah, that's pretty good. I've got a 2200 microfarad here, a little bit bigger. Let's see what she makes of that. So that's 2200, and taking its time. Here she comes, yeah, 2.089, so nearly 2.1 millifarad. So yeah, that's pretty close. Can't argue with that. And the largest capacitor I've got to hand at the moment is 4700 microfarads, and it's quite old, so wouldn't expect that to be particularly close. But let's see if the Kaiweets can make any sense of 4700 microfarads. So 5.197 millifarads, or if you like 5198 microfarads. So yeah, it's managing to measure that large capacitor too. So that's quite a decent range of measurement. Yeah, good. Okay, so another handy thing for electronics hobbyists is to check out diodes. So I've got a couple of diodes here. So first of all, a silicon one, and in that direction, as you can see, it's effectively open circuit. Let's chisel it round, see what we get. Yeah, about 0.6 volts, which is what you'd expect across PN junction for silicon. Let's try this one. And again, open circuit that way. Let's try see what its forward bias is. And this 0.4, so I suspect that's a germanium diode. It's been lurking in my tray for many years, so it probably is. And those voltages check out on my bench meter as well. So yeah, it does nicely on diodes too. Okay, in continuity mode, we've obviously got the beep when we touch. So yeah, there is a slight delay. I know a lot of people are critical of meters who have a slight delay. I have to say pretty much all of my meters do that, and I'm just used to it. Tells me what I need to know, so that's good too. Okay, so one of the things I know people are always quite interested in with meters is how easy it is to change the fuses. So just remove the rubber boot from the meter. There's just 4 screws to remove here. You don't need to remove the battery, and then the back comes off nice and easily. Feels quite sturdy. It certainly isn't flimsy. There's your 2 fuses. It's quite good to see there's a nice big gap, plenty of room between the traces on the high voltage side compared to the low voltage controlling circuitry, so that's good. 2 spring contacts there for the batteries from the other half of the case. So yeah, nice and easy to change the fuses. They're just snap in and out. No soldering required. So there you go. Okay, so general impressions of the Kaiweets HT118A digital multimeter. Quite favourable. Feels nice and solid, well made. Switch seems okay, everything seems to work. Quite happy with the ranges. From an electronics hobbyist point of view, it does pretty much everything you'd need. It also does microamps, which is also obviously quite handy for electronics. Quite a lot of meters at this sort of price point don't always include that, so that's good. The leads that come with it are more than adequate. Again, for the price point, I think they're perfectly good. I'm certainly not qualified to comment on its category ratings and voltage. It isn't something I'm qualified to speak about, but certainly seems perfectly adequate. Thermocouple, nice manual that makes sense. So yeah, if as I said, I've been provided this by Kaiweets Tools to evaluate, and if I'd bought one, I'd be more than happy with my purchase. So I'm going to use it now on a fairly regular basis here in the lab and see how she gets on. So you'll probably see it in use, coming up with some measurements for some of the projects I'm involved with. So yeah, I think that's all right. Okay, well that's almost it for this video. I hope what I've been able to show you about the Kaiweets meter has been useful. I think from a hobbyist perspective, it's more than adequate. If I'd bought that, I'd be quite happy with my purchase. Seems to do the job nicely and seems reasonably accurate, so no complaints on that front. This came from Amazon. I'll put a link down below to where you can get one from Amazon. They're about £30 in the UK, something like that, so a very reasonably priced multimeter with a sensibly written manual that you can actually understand too, which is another bonus. Okay, I hope you've liked the video. If you have, please click the thumbs up. If not, you can click the thumbs down. Either way, thanks very much for watching. Please consider subscribing, and we'll see you on the next one.